So before getting started, let me introduce myself. My name is Krishna. I have 14 plus years of experience. I do teach in different cloud technologies, and I do teach in Azure, AWS, GCP, and different databases like Snowflake as well. So I worked in multiple cloud data engineering projects. So presently, my designation is a technical lead in one of the reputed organizations. I worked in multiple data warehouses, like I worked in Amazon Redshift, I worked in Azure Synapse, I worked in Google BigQuery, I worked in Snowflake as well. And Snowflake is one of the most top leading data warehouses out of the present market, and that is why it is gaining much traction in the market, and it is having very good interviews as well. So what exactly is Snowflake? This is a data warehouse basically. So we'll be using this for our data engineering purpose, that is for cloud data engineering purpose. So what exactly is cloud data engineering, and how Snowflake is connected to it? And what is the significance of Snowflake in this? And apart from that, how can we integrate DBT with Snowflake, and how can we integrate Airflow with Snowflake? These are the things we'll try to discuss on a high level, and I will share the course content as well. We'll go through the course content, and we'll see like what exactly we're going to discuss all these things in this particular course as well. Okay, so before that, let's understand what exactly is cloud data engineering. So if you see here, we have mainly two terms like what is data and what is cloud. So let's understand what is data and what is cloud, so that can easily connect the dots here, like what is the scope of cloud data engineer and what is data warehouse. Data is nothing but collection of raw material in unorganized format. So this is simple definition of data here. So let's take some sample numbers: 101, 102, 103, 104, 105, like this. So if you see these numbers, it can be anything, like it can be any employee ID, it can be any student ID, or it can be any customer ID. It can be anything. Okay, you can't predict what exactly this one is. These numbers are the same way. Let's take any names like Ganga, Yamuna, Kaveri, Krishna, like this. If you take some names, these names can also be anything. It can be any random names, like it can be any student names, or it can be any customer names, or it can be any kind of names, like any employee names or student names or customer names or any kind of names here. Okay, this is nothing but a collection of raw material. This is kind of an unorganized format here. It is not in a proper organized format, you can say. So it can be anything. Data can be anything here. So in the same example, let's say for example, I give some metadata names here, like let's say for example, for this employee number, for these numbers I will give it as employee ID. And here, if you see here, I give it as employee names. Okay. Now, if you see here, I'm giving some particular data, or I'm giving some particular column names. I'm giving some particular exact meaningful, some kind of names for this particular data here. Okay. So 10, now you can say that 101 is nothing but it is an employee ID. Now you can say that Ganga, Yamuna, all this has a employee names here. Okay. In the same way, whatever data we are getting, if you don't have any meaningful names for that, if you don't have any particular format for that, then we can call it as a data here. But if it's here, we are giving some particular names, or we are getting some particular column names for this. We're getting some particular identity for this. Okay. When you give some particular identity for this, obviously this will come under a organized format. Some meaningful data it is there. It is having some meaningful data. Okay. Now you can take it as a information. Now this is called as a information. Now if you see, whenever you are getting data in organized format or meaningful format, such kind of data, we can call it as information. Okay. These things are simple example. This particular data, we can call it as a information here. Okay. Whenever you are having some kind of meaningful data, some kind of organized format, such kind of data, we can call it as a proper information, you can say. Okay. So this is a generic example, whatever I have taken. Let's take a real-time example in a real-time scenario here. Let's say, for example, I have a Axis Bank, and this bank, it is having around 1,000 branches across India. And out of this 1,000 branches, I want to cut down. I means management. Management want to cut down 100 branches out of this 1000 branches. Okay, so if you want to cut down 100 branches out of 1000 branches, what would be the criteria here? So just like that randomly you can't cut down all these things, right? Just like the randomly you can't cut down 100 branches like randomly, and you can tell that these 100 branches are it has been taken out. Just like that you can't say like that, but there should be some criteria here. What should be the criteria to cut down these 100 branches? Any guesses?
Performance of each branch.
Correct. So performance in terms of finance, I can say. So it can be financial performance, or you can say indirectly you can say sales, turnover, or you can say profit or loss statement. So this is the main criteria. The manager wants to cut down this 100 branches out of this 1000 branches. So this would be the main criteria here. Okay. So why exactly they want to cut down this 100 branches? To reduce the cost burden. So this kind of decisions generally will be taken care by business people or any high level management or say any kind of CEOs, okay, who is in a position to take the decisions. Okay, so which branch they need to close, they which exact branch they need to close, they will try to understand each and every branch. What is the total turnover and what is the total profit or loss for each branch? Depending on that, they will do analysis and they will take decisions which branch they need to cut down. Okay, so these type of decisions they will make on top of this particular profit loss statement or a kind of analysis, whatever reports they fetch here. Okay, so to fetch this report, so generally in banking sector we have multiple departments, like we have savings department, we have a loans department, we have credit card department, like we have demat department. These are different departments available in the banking sector here. Okay, any banking sector, these are the basic departments which are available in any kind of a bank here. Okay, so for each and every department, let's say for example any customer is coming into the bank and he is going to the savings department and he wants to open any account over there, and after opening the account he has done some transactions, like he has deposited some amount in that savings account. Okay, whatever transactions he has done, that will be handled by the savings department here. Basically any department they will handle the transactions here. This will happen in every department. This is the basic thing, it will happen. Okay, the same way loans department also, any ex customer, they goes to the loans department and they will apply for a two-wheeler or a four-wheeler loan or any gold loan or any kind of loans. So basically this loans department also they will handle the transactions from the customer side, and same goes with credit card and the demat department. Okay, so whatever transactions they have handled, they need to store those transactions. Basically they need to store those transactions. This is a simple criteria for any kind of department. They'll store the transactions. Okay, but where exactly they will store? So let's say for example the savings department, they store all those transactions in JSON file. In the same way credit card department, they store all these transactions in XML files. In the same way the demat department, they store all these transactions in database tables. So let's say for example in savings department we had a total turnover of around 2 crores, and in loans department we have a total turnover of around 5 crores, and in credit card department we have total turnover of around 6 crores, and demat department we have total turnover of around, let's say for example 3 crores. So this is the total turnover happening in each and every department per annum, you can say. Now what you want to do here, if I want to know the total sales turnover, what exactly I need to do? I need to basically sum up all these things. I need to do the total turnover of this branch here. So how can I do the total turnover of this branch? So I need to sum up all these departments, right? Savings department, plus a loans department, plus a credit card transactions, plus a demat transactions. I need to sum up basically all the transactions. Saving transactions I need to sum up, and then loans transactions I need to sum up, and the credit card transactions I need to sum up here, and then demat transactions I need to sum up. But if you see here, each and every department, it is in a different mode here, as in different format actually. Okay, so if you see here, we are having this data in different formats. So if you see here, savings department, this department, it is having the transactions in text file. It is savings.txt file, right? And in the same way, loans department, we are having this in a JSON department, loans.json file. In the same way, credit card department, it is in a XML file, loans.xml file. The same way DMAT department, it is in a database tables. Okay, that is, you can say, DMAT database. So if we are having data in different formats, is it possible to perform summing operations here if the data is in different forms? Obviously, it's not possible to do summing operation. But what is the like how to overcome this? So if I want to overcome this challenge, basically what I need to do is I need to convert all these different formats into a single format here. So whatever data, if you see here, basically whatever data available in text format or JSON format or XML format or database tables, it is not going to achieve our requirement here. Our requirement is to get the total sales turnover. So this kind of format, you can call it as unorganized format, or you can call it as some kind of a meaningless format. It is not in a unique format. So basically this kind of unorganized format, we can call it as a raw data, or simply data, you can call it as a simple data here. Okay, whatever we have discussed here, this is a generic example. Same thing we have discussed with the help of a real-time example here. So whatever data, this is available in different formats, that is the different unorganized formats. That kind of pointers, you can call it as a data here. Now to achieve my requirement, what exactly I need to do here? I need to convert this savings.txt file into savings table. I want to convert this into a unique table here. Okay, I will convert this into savings table. And loans.json file, I will convert this into loans table. And after that, I have credit card.xml file. I will convert this into credit card tables. And the DMAT, it is already in a tabular format. I don't need to convert this. I will just migrate whatever data is there in DMAT table into my table here. I don't need to convert. I just migrate this data. That's it. Okay. So in between all these above tables, if you see here, everything is converted into tabular format. After conversion, in between all these tables, can we able to do summing operation? No. Tell me, is it possible or not? Can you able to do summing operation after converting to single format, that is the database tables? Obviously, it is possible, right? So how is it possible? We can write simple SQL queries here. We can do the summing operation. That is the total turnover here. Okay. So that is the total turnover we can write. So just by writing sum of whatever tables we are getting, we'll just load all these tables into our database, and we'll just do the summing operation, and we will load the total turnover, whatever operation we have done. So that is the final output, you can say, that will be loaded into a target database. So with the help of this total turnover, we will get the some kind of KPIs we'll get, and after that we will do analysis on top of this and take decisions. This is what we will do here. And in this entire example, what are the different operations we have performed here? In this entire example, what are different operations we have performed here? Basically, we have collected the data, that is raw data, from different sources. Then we are converting the data into organized format. For the purpose of doing analysis and to take decisions. And we are converting data into organized format for the purpose of doing analysis and taking decisions. This is what we have done, right, till now. So if you see here, whatever we have done till now, collection of data from different sources, then we are converting the data into organized format for the purpose of doing an analysis and taking decisions. This is called as data warehouse process. Okay. So this data warehouse process, this is just a concept we are trying to achieve here by just doing step-by-step process, like first collecting the data from different sources, and we are converting the data into organized format for the purpose of doing analysis and taking decisions here. So till now what we have discussed, we have discussed what is data. So now after converting the data into single format, this is kind of organized format, you can say. Okay. So this organized format, you can call it as a information here. So we have discussed what is data, what is information, and what is a data warehouse process. Okay. And if you see in this data warehouse process, what are the operations we have performed here? What are the operations performed in data warehouse process? So first thing what we have done, we have collected the raw data here. Okay, collection of the data we have done. After that, converting the data we have done. So what is collection of the data? Collection of the data is nothing but a extraction of the data here, and converting the data. So converting the data is nothing but we are doing the transformation of the data here. And finally what we have done, we have loaded this data into the final target. So extraction, what is that? Extraction is nothing but E here, and transformation is nothing but a T. Loading the data is nothing but a L here. Okay. Basically, we have performed the ETL process. Whatever we have done here, we have done the ETL operations here. Okay. So whatever we have done here, this process is nothing but a data engineering process. So, as part of a cloud data engineer or a simple data engineer, what exactly they will do is they will build data pipelines. This is the scope of any data engineer, any Snowflake data engineer or any Azure data engineer, AWS data engineer or GCP data engineer, any kind of cloud data engineer. This is the basic scope of any kind of data engineer. They will build data pipelines basically where data will be extracted, and they will convert that raw data into some kind of meaningful data as in they will apply business cases, they will apply project requirements as part of their process, and after applying the project requirements they will transform the data as per their requirement, and finally they will load the data into data warehouse. Okay, so for that they have many tools in the market which we have used. You can say there are many tools which in the market which we have used, like as part of this data engineering process. So initially, before almost 10 to 15 years, we used to have some ETL tools like Informatica, Abnisio, Data Studio, this kind of ETL tools we used to have. And after some years, like due to licensing and other maintenance issues, people started, our business have started using this Hadoop framework, which is a open source. And I can say like Hadoop, we can actually process large amounts of data, large volumes of data with the help of Hadoop or big data technologies. Okay, that is the next thing which came upon. But again, they have some challenges like everything will be on premise. And after that, you can see last 5 to 10 years, everything is moving to cloud here. Like we have AWS cloud, we have Azure cloud, we have GCP cloud. Everything has been moved to cloud. During that process only, like we have Snowflake as well. Okay. So Snowflake is coming to the picture. I can say in the last 5 to 10 years. And this Snowflake, they don't have any on-premise servers as well. Directly, they have launched as a cloud data engineering only. They have launched directly on the cloud itself. This particular data warehouse, Snowflake is also a data warehouse here. So what exactly Snowflake means? Snowflake is nothing but a data warehouse. As coming to the picture as a data warehouse directly hosted on top of cloud. Okay. Snowflake is not a cloud provider. We have different service providers for a cloud, AWS, Azure, or GCP. Snowflake leverage those cloud technologies and they will host their data warehouse on top of cloud. Okay. As of now, I can say that more than 70 to 80% they are hosting on top of AWS cloud only. They have connectors to GCP and Azure cloud as well. But 80% of the Snowflake projects are working on AWS cloud only because they have some inline process or they have some tie up with AWS itself, and they are hosting directly on top of AWS cloud. And again, AWS is the top cloud platform. That is also one of the reason, and due to that reason it is basically hosting on top of cloud itself. Okay, before going further, so we'll understand what exactly is a cloud on a high level and why exactly we are using cloud here. So a simple definition of cloud here. So cloud, you can say like cloud is a global network of remote servers, that where you can store and process data, where you can host all the servers, everything you can do here. Okay, basically what you can say is it refers private or public network or any internet from where we are going to get all the required services. Like we are using Google Drive on a day-to-day basis in our real time. So we are using Google Drive here. What exactly Google Drive will do? We can upload all the documents based on a requirement here on top of a Google Drive. Okay. Just you have a Gmail account, that is enough for you. If you have a Gmail account, just upload all your documents on top of Google Drive, and that you can use it as a storage as a service here. Okay. That is nothing but cloud computing. So next is like cloud computing. So what is cloud computing? What is cloud computing? Cloud computing is nothing but as part of cloud computing, it will deliver different computing services over the internet. Okay. What is meant by computing services? What are the different computing services we have? Okay. So we have different computing services, like we want to host servers that can be achieved with the help of cloud here. I want storage. I can process the data. I can store the data on top of cloud. I want a database services that can be achieved. I want a networking that also can be achieved. I want some softwares like Python or Anaconda or any kind of a Spark technology, Spark software, PySpark I want to use. Okay, I want to use Hadoop. Those kind of softwares you can get on top of cloud. I want analytical softwares like any kind of analytical service softwares also you can get. I want a business intelligence setup. I want a data warehouse basically. All these computing services you can get on top of cloud directly. Okay. So basically, if you see before 5 years or 10 years, whatever you want to achieve, like let's say, for example, you have set up a software company and you want to start a project. You have a client which have given a project and you want to start a project. So before 5 to 10 years, if you want to start a project, you need to set up everything physically. Physically, as in you need to start from scratch. You need to set up office location. You need to set up servers. You need to set up physical machines. You need to set up networking components for the servers. So you need to install all the softwares. You need to install all the softwares. You need to install all the security patches, and after that, you need to do all the maintenance activities on top of that. Okay, only for the setup, it should take at least 1 month or at least 15 to 20 days. But nowadays, like with the help of cloud, you don't need to set up anything manually. Everything has been fully managed by cloud service providers. We have many cloud service providers in the market, like AWS, we have Azure, we have GCP, we have. These are the top three cloud providers. Apart from that, we have some more cloud providers as well. As in, we have Oracle, we have IBM Cloud. But top three are AWS, Azure, and GCP. Okay, so this is about cloud here. And when it comes to Snowflake, so this Snowflake, whatever data warehouse, Snowflake is nothing but a data warehouse. Yeah? It is directly hosted on top of this cloud service providers. Okay, they will leverage this cloud services, and we can host directly on top of this AWS or Azure or GCP. So this Snowflake is giving a provisioning here to connect with the AWS or Azure or GCP, and we can directly use that particular cloud service provider, and we can just connect to that cloud service, and we can leverage that cloud service basically. That is kind of provisioning we have with the help of Snowflake here.
Quick question. You said Snowflake is a data warehouse. How is Snowflake different from Databricks?
Okay, fine. So Databricks is entirely different. So Databricks, when it comes to Databricks, Databricks is not a data warehouse. So Databricks is a platform where you can do all Hadoop related activities. Where you can do all, not only Hadoop, you can do any kind of data engineering activities here. And you can host your Spark, or you can host your Hadoop related frameworks on top of Databricks here. Okay, it is just a platform. It is not a data warehouse. Databricks is just a platform where you can do all your data engineering activities. You can run your PySpark code, or you can run your jobs, you can run everything on top of Databricks. Okay, so Databricks is entirely different from Snowflake. Snowflake is a data warehouse. Snowflake, we have different data warehouses in the market, so that can direct competition for data. Snowflake here. Snowflake is one of the data warehouse. We have GCP BigQuery. We have AWS Redshift. We have Azure Synapse. So these are the direct competitors for Snowflake here. And Databricks is not a data warehouse. It is entirely different. This is just a online platform where it is a cloud platform again, where you can run your jobs, where you can run your workflows, where you can write your PySpark code, and where you can do all your activities on top of Databricks. So data engineering activities basically. And this is nothing but this is entirely a data warehouse. These are the direct competitors for Snowflake here.
One question: this Azure Synapse and this Synapse Analytics both are same, right?
Yeah, this is
Both are.
called Azure Synapse Analytics. But why Snowflake? So we have this many data warehouses. Why Snowflake? Why Snowflake is a gaining market here? So Snowflake has some distinguished features here, where it is a gaining market. It has a very powerful features here when compared to other data warehouse. And if you give a simple search, like just give a simple search in any AI tool, like Microsoft Copilot or anywhere, what are the top data warehouses presently? Okay. So if you give this, Snowflake will comes under the top data warehouse here. And after that, Databricks, we are having some feature called Lake House. Okay, not completely Databricks. On Databricks, we have something called Lakehouse here. It will combine data warehouse and data lake capabilities. So we can leverage this Lakehouse as well in Databricks. And after that, we have Amazon Redshift, Google BigQuery. Now this Azure Synapse, it is getting changed to Microsoft Fabric. They have did some changes on top of that, and they have launched a product called Microsoft Fabric to just give direct competition to these data warehouses. And this Microsoft Fabric, maybe a couple of years or after 3 or 4 years, maybe it can gain traction and it can give direct competition to Snowflake. But as of now, I can say Snowflake is the leading data warehouse in the market here. And after that, Databricks, the platform under Databricks, we have something called Data Lakehouse that comes from Databricks here. Like how BigQuery is coming from GCP, how Redshift is coming from AWS, how Synapse Analytics is coming from Azure. So this Azure Synapse Analytics, it is converting to Microsoft Fabric. So why Snowflake? It is having almost, I can say, 50% of the market in data warehouses. Okay. In data warehouse, it is having almost 50% of the market, and remaining 50% it is taken by the remaining data warehouses. If you see here, the remaining data warehouses like BigQuery, Redshift, Fabric, Data Lakehouse. So these are the different data warehouses which are available, and remaining 50% is taken care by those data warehouses. Apart from that, we have another data warehouse like Oracle Data Warehouse, Teradata, Vantage, IBM. It is very less. Their contribution is very less than 5% or 10%, I can say, not more than that. And along with this Snowflake, we'll be covering DBT, and we'll be covering Airflow as well. So what is DBT? DBT is one kind of a tool where you can do all your ETL activities here. Okay. On a high level, I can say we can just integrate with the DBT, and we can increase the performance here on this ETL operations or data engineering activities. That I can say. And apart from that, we have something called Airflow. Airflow is nothing but workflow orchestration. It is a workflow orchestration tool. So what exactly we are doing? We are building the data pipelines here. Manually, we are building all the data pipelines. So after we are done with the manual process, we will automate that process. Whatever data engineering activities we are done, that is building the data pipelines, we will just automate that process here with the help of Airflow. So that is nothing but a workflow orchestration tool. Okay. So these are the things we'll cover. And coming to course content, this is a course content here. First, we'll start with what exactly is Snowflake, its history, and the introduction of Snowflake, and I'll show you how to create a trail account for Snowflake. And after that, some admin things we will see, like what are the privileges we have on top of Snowflake. And after that, we'll start with simple ingestion process, that is data ingestion in a Snowflake, and we'll build a data pipeline. And then we'll see a Snowflake special features here. What are the different features like time traveling and data sharing, virtual warehouses, micro partitions, how will we do clustering, metallized views, data masking, all these things we'll see here. And after that, we'll integrate Snowflake with Python, and we'll set up a Python here, and we'll see how to do this pipeline into connectors as well, Python connectors and all these things on top of Snowflake. And finally, we will integrate AWS with Snowflake, which is a cloud here. So as of now, as I said, 80% of the Snowflake it is hosting on AWS only because of the tie-up or because of their close interaction. So we can we'll just high level we'll discuss how can we integrate with AWS, and after that we'll integrate with DBT, and finally we'll integrate Airflow with Snowflake as well, and we'll do the workflow orchestration basically. So as part of this modules, what I will do is I will explain an end-to-end project as well. like any banking or any kind of domain, retail domain, and we'll explain an end-to-end project on Snowflake, leveraging all these services like AWS, DBT, and Airflow. We'll build a data pipeline manually, and after that, with the help of DBT, how exactly we can leverage that, and finally, we will use this Airflow for the workflow orchestration as well. After building the data pipeline, we'll automate the entire data pipeline. So this is the course content, and this is what we'll be covering in these sessions.